So thanks for that, Andy. So with the PureFlex system, one of the things that IBM did, and I didn't put a slide in here on this, is they brought out 3 pre-configured versions of it. The first one is called Express, the second is Standard, and the third is called Enterprise. And that just has to do with some differences in the default components. So basically with the PureFlex system, as Andy mentioned, you're going to get some storage, you're going to get a chassis with some nodes in it. We call them nodes or IT elements now. And you're going to get a Flex Systems Manager. There'll also be a top-of-the-rack switch. So I'm going to start out by talking about the chassis. And basically the chassis is a 10U chassis. It's, at this point in time, the storage is actually external to the chassis. There's a statement of direction that come October, the storage, you'll be able to have it inside of the chassis if you want. So in that chassis there are 14 half-width bays. So you can have up to 14 half-width nodes, or you can have 7 full-width nodes, or any combination thereof. Depending on whether it's an Express, a Standard, or an Enterprise, there'll be a different number of power supplies and a different number of cooling fans. The Express, for instance, has 2 power supplies and 4 cooling fans. You can have more than that if you want, but that's the minimum that you require. And then the chassis management is all integrated and controlled, and all of the nodes are controlled as well through the management node that you will put in there, which is basically a half-width X-series server that's running some specialized software that we call Flex Manager. And Andy's going to go into that in more detail later. So if you look at the chassis from the front, what you'll see is usually at the top you're going to see the Flex System Manager, and then you start to see the nodes. In this case we have an X240, which is an X-series node, and we have a P260. We have 2 of those and a 460. I'm going to go into the actual nodes in more detail, but basically the nodes in the chassis are either going to be Intel or Power and the Flex Systems Manager. As I said, in October, they're going to add the option for you to put the storage in there as well. So as you can see, it just basically looks like a bunch of things put in the node. If you look at the back, that's where you start to see the meat. You can see the fans, and you can see, right, in this case, there are 8 of them. You can also see that there are a couple of chassis management modules. Those chassis management modules internally in the chassis are cabled up to all of the nodes for the networking and for their fiber, and then the chassis management modules connect to the switches, and that's also with the chassis management modules. That's how we actually control the things like firmware and how we manage the individual chassis. So in terms of the nodes that are currently available, actually there's one missing off this slide because it only got announced about 3 weeks ago. From an Intel point of view, we actually have the X220 and the X240. And then from a Power point of view, we've got the P260 and the P460, which is a full width. And then we also have our Flex System Manager. So in the next couple of slides, I'm going to go into those in more detail. And the first of these that I'm going to cover is going to be the X240. So this is a Intel E5-2600 with 2 processor boards. It's using the Sandy Bridge sockets, and it can handle up to 24 DIMMs. It actually has a 10 gig converged module on there. It has up to 2 internal disks. One of the things that we have to be careful about when we're configuring them is that the memory that goes in all of these nodes comes in either low profile or very low profile, and the larger DIMMs are actually low profile. What does that really mean? It means that if you're doing SSDs, you can max out the memory, but if you're doing hard drives, which are a little bit bigger than the SSDs, then you have to use the very low profile memory, and it means that you don't get quite as much memory as you could. So this module actually offers you the ability to put ESXi, the VMware product, on a flash key and actually have that installed. And basically the intent is that, for instance, you might want to put things like your web servers on these, maybe have a database on a P260. have them, or P460 rather, have them inside of the rack and all intercommunicating with each other. And when I talk about networking, you'll understand why that becomes important, because you have the option of avoiding what we call the north-south problem. Then we get on to the power nodes, and this is the P260. This is a half-width. Well, when they say standard width in these slides, they really mean half-width. It's got 2 sockets of power 7, up to 16 cores. Both of the sockets are 8 cores. It has 16 DIMMs, and you can go up to 256 gig. Now, if you do SSD drives, that is true. If you do hard disks, then you can only use the 4 and 8 gig DIMMs, so you would be maxed out at 128 gig of memory. This has dual mezzanine cards. By that I mean we'll have one card that will handle networking and one card that handles 8 gig fiber. And then those are all cabled back to the chassis management module. So we also have the Linux-only power mode. And this node, again, is a 12 to 16 core 2-socket power 7. It will run Linux on power, which is going to be either the RHEL or the SUSE Linux. And basically what they've done is they've taken the node and they've given it a discounted price if you only run Linux on it. You cannot run AIX on it. So it will support PowerVm, but it does give you the ability to do Power Linux. And both Andy and I have done a significant number of installations with Linux on power, and it performs very, very well. So then we have the P460, and this is a 4-socket forward node. So you still have the 2 hard drives or the 2 SSDs, but now we have 32 DIMMs of memory. Again, we can go to 512 gig, but if you go with hard disks, then we can only go to 256 gig because of the difference between the size of the hard drive and the way they're positioned over the memory. We've got 4 sockets of 8 cores, and by the way, there's some different speed options and so on for all of these. And we have 4 mezzanine cards, so we can have 2 fiber mezzanines and 2 networking mezzanines, which is very useful because that now allows us to run two VIO servers, one from the internal disk and one from the SAN. Additionally, the storage that is integrated into the rack is the D7000, which is the disk subsystem that we can use to virtualize other storage, but it also allows us to do things like non-disruptive migration of data, thin provisioning, and those kind of things. It has a very, very nice interface. If you've ever seen the XIV GUI, this has a very similar GUI, and it's very, very easy to manage and orchestrate. What's nice is that this is all integrated into the Flex Systems Manager, so that all of that provisioning and everything takes place from there. When we start to look at interoperability, you can see that the V7000 basically allows you to virtualize external storage. It's going to integrate with the storage control application that runs under FlexSM, so it'll do discovery, inventory, monitoring and alerting, and all of the configuration and provisioning from a simple GUI. And that's something that's very powerful because when you're having to do line commands and some of the more complex storage things, it makes things just take a lot longer to do. So that is also the storage that we believe is going to be integrated in later on. All right, so now we start to look at the network. And basically, one of the things that they've done is they've actually integrated the network switches into the rack so that you don't have to, when you buy a PureFlex system, you don't have to run out and worry about additional network switches, etc. All of the networking within the rack is going to be cabled up to the in-rack switches, and then the thing that you will have to provide is the switch ports for the uplinks from there to your public network. So we have a number of different options, and what I like about this slide is if you look over at the left, one of the common problems that we have, and this is a particular problem for trading companies, is network latency. Whenever a node wants to talk to another node, it has what we call the north-south problem. It has to go all the way up to the switch and then back down to the other node. And if you hit enter a couple more times, Andy, I think all the automations start. Basically what they do in the Flex system is that if a node within a chassis wants to talk to another node within the chassis, then it does it directly within the chassis. It never leaves the chassis. So we call that a switch from north-south to east-west. And that's what these little dots moving around are showing you. So effectively, we significantly reduce switch latency, which is really big if you have applications where latency is king. And that I definitely see that in things like trading, but I know there are a number of other places that occurs. What this means is that when you're designing your chassis, you want to try to design them so that things that go together, for instance, if you have web servers that go after a particular database server, maybe you want to have those in the same chassis so that you never have to go up to the switch if they're talking to each other. And that's the point that it's making here right now, is that communication stays within the chassis. And by the way, all the cabling behind the scenes for those nodes is 10 gig. It may be 1 gig going up to the public network, but it's 10 gig within the chassis always.